Hi students, welcome to my lectures on thermodynamics. In the last two lectures, we have discussed about the first law, which consists of internal energy is equal to heat plus work. And let us concentrate on this work today, how to evaluate the work. And second most important thing is why there is a minus symbol in the formula. Okay, if you want to calculate the work, especially the displacement work, you get to see the minus number. Displacement work is equal to minus integral P dV from volume V1 to V2. Okay, if you see this kind of minus, it has some meaning with it. If you remember, during my earlier lectures, we were discussing about the sign convention. That means there is a system, it could be the glass of water or it could be a piston and cylinder assembly. If you provide anything to the system is positive. If we are getting something from the system, that means by the system is negative. So if you don't put this minus symbol, you cannot follow this sign convention. Today's I will explain you with this simplest example possible. As we are discussing about the work and heat are different forms of energy. Okay, only the internal energy will be there in the system. Okay, you have to transfer this work or extract the work. You can supply the heat or you can extract the heat. These are the things you can able to do. And if you remember the work, there could be many works, because in majority of the books, while we were going through the first year of engineering or third semester of engineering, we get to learn the thermodynamics subject. And in the thermodynamics subject, people often refer to piston and cylinders. I told you, right? Thermodynamics applies everywhere, but as majority of the books are giving the example of piston and cylinder because thermodynamics have developed during the heat engines, working with the heat engines and IC engines. So when you talk about the engines, apply the thermodynamics to the piston and cylinder. In general, it applies to everywhere. Okay, when you talk about the work, you can supply the work or extract the work from the system. There are many kinds of works are there. Displacement work, shear work, electrical work, flow work, chemical work. There are number of works are there. I mean, these are the different forms of work. Something in an electrical sense, something in displacement means piston and cylinder movements, something about electrical and flow works. These are the different forms of work you can see. In today's lecture, we are concentrating on this displacement work. Rest everything you can neglect at this moment. So displacement work is referred to the formula. Displacement work is equal to minus integral V1 to V2 P dV. Okay, minus should be there. Okay, if you don't use minus, then you are not following the sign convention. So let us take a small example. There is a piston and cylinder assembly is there. The initial state is P1 V1, final state is P2 V2. That means from initial state, from the 1 to 2, volume expansion takes place. That means expansion means system has done something to the surroundings because of this expansion. That means if the system is done something to the surroundings, if I calculate how much work has been spent in the process, it should be negative, because anything by the system is always negative, anything to the system is always positive. So if you use this formula, automatically this will take care of. That is why I have specially given. So to deliver the concept, I told you, right, you can bring the system from state 1 to state 2 by different methods or different processes. State 1 to state 2. Let us take example. We brought the system from state 1 to state 2 at the constant pressure process. You see, pressure is also initial state, the pressure is P1. Final state, the pressure is also P1. That means pressure is not changing, only volume is changing from V1 to V2. That means the pressure, because of these expansions, the inside the pressure remains the constant between state 1 and state 2. That is called the constant pressure process. If such is the case, how much amount of work is involved, that work is positive or negative. Okay, this is the example. If you see, state 1 is before expansion, state 2 is the after expansion. Let us use the formula. Displacement work that has happened when we bringing the system from state 1 to state 2 is nothing but minus integral V1 to V2, that means state 1 to state 2, P into dV. Okay, as you know, it's a constant pressure process. If it is a constant pressure process, then initial pressure equal to final pressure is equal to P, which is equal to constant. During this expansion, the pressure inside the cylinder is not changing, only volume is changing. So in such cases, P1 equal to PT equal to P is equal to constant. So if anything is constant, it comes out of the integral. So minus P V1 to V2 dV, integral V1 to V2 dV is nothing but V between the limits V1 to V2. Okay. Finally, the displacement work is equal to minus P into V2 minus V1. V1 is the initial state, V2 is the final state. For example, let us apply some example to this formula and check whether it is following the sign convention or not. The pressure, let us example, the pressure inside this expansion process is around 1000 pascals and initial volume is 1 meter cube, final volume is 2 meter cube. Okay, before expansion and after expansion. Calculate the work expended during constant pressure process. That means this is the formula for the constant pressure process to calculate how much amount of work is required. Then let us see. Okay, apply the formula WD, displacement work is equal to pressure minus 1000. That is, pressure is minus 1000. And what is the V2? V2 is 2 meter cube and V1 is 1 meter cube. That means minus 1000 joules. So minus, that means, because it is true, because as we have expected, right? Because of this expansion, system has something done to the surroundings, because work has been transferred from this system to the surroundings. That means automatically anything by the system on the surroundings will be negative. That is why you get the minus 1000 joules of work is involved in the process from the expansion from P1 V1 to P2 V2. And if you take the reverse of that, that means if this is your first and this is your second state, that means compression process. Earlier example is expansion process, second example is compression process. When compress, initial state and final state, that means surrounding has to do something to the system to compress the volume. That means it is the reverse process. Let us see what happens in the reverse process. Same pressure. Here also we are following, direction is this way. From state 1 here, state 2 here. That means this is state 1. Now this is state 1, this is the state 2. Pressure is 1000. Same formula applies. V1. Now the initial volume is 2 meter cube. Final volume is 1 meter cube. That is a V1, V2. Calculate the work expended. So apply the formula WD is equal to minus P into V2 minus V1. Pressure, that is 1000 into V2 minus V1, this is 1 minus 2. So what happened? Okay. You got the positive number here. Okay, it is, of course it is true, because to compress the system, the surrounding has to do some work on the system. So anything to the system is positive. That is why in the compression process, the work is positive. That means you have to, because anything to the system is positive, that is why here it is 1000 joules, it is minus 1000 joules. I hope now you have understood what is the reason for this minus symbol in the many books. If you follow older books, this minus symbol will not be there. And this is the latest sign conversion you can talk about. So minus symbol you are going to find in the latest books, because universally people following this, anything to the system is positive, anything by the system is negative. Earlier it is different sign convention people are following. Don't worry about it. Try to follow the same sign convention. So things will be more clear. Okay. Thank you. Let us meet with a new lecture.